Ooh, yuck. All right, so in this short video, we're going to go through and show you how to resolve vectors. Now, it's really important that if you know your trigonometry, you should be able to be fine with this stuff. I've got a tug-of-war question here, if you like, and we've got f of d, we've got 180 newtons, which is a vector because it has a magnitude and a direction, pulling us this way. Shh. We have 220 newtons going to the right. Now those are going to oppose each other and effectively cancel out because they're on the same plane, aren't they? Now the force of 200 newtons going up and 220 newtons going down. So what we need to do is, if you think about it, if I had 220 newtons pulling to the right, 80 newtons pulling to the left, that is going to be a resultant. If you like, what we can say is we can say that given the fact that to the right is positive, and to the left is negative, we could say that the resultant force in the horizontal is equal to, and it can be negative result, but we've got 220 to the right, which is positive, minus 180, which is equal to 40 newtons to the right. So what we've got is we've got 40 newtons of force to the right, which is of course, or to the east if you like. Now, what are we going to have? The same thing, we're going to have a positive value of 200 newtons subtracting 220 newtons, which is actually going to be a 20 newton force. Now, I haven't drawn the arrows to scale, but we've got a 20, effectively what we've got is a 20 newton force like so. Now, we've now got 40 newton force. We know that there's going to be the resultant force. If I did head to tail, so what I can do is I can then grab this 40 newton force and I can then actually do something like this, okay, and bring that down there. So that now, when we're adding vectors, we can add them like so. So now our resultant force is going to be in this direction here. This is going to be my resultant force, which has a magnitude and a direction. Now, I guess it would sort of make sense that if we worked out that the angle is, we could use that using Pythag. So therefore, we can say that the resultant force, is using Pythag, and I'm going to be skipping a step here, that is equal to the square root of 20 squared plus 40 squared, which 40 squared is 1600, so that's the square root of 2000 newtons. But we're not done yet because we need a magnitude and a direction. Now, what did the square root of 2000 newtons turn out to be? 44.7. Okay, so let's just say that's approximately 44.7 newtons. But we're not done yet because we want to then find out our direction. But of course, with this, if I've got a horizontal and a vertical component, we're always going to be using tan, opposite and the adjacent effectively. So what we want to do is to find theta, we can say that tan of theta is equal to opposite over adjacent, which is 40 over 20, which is equal to 2. So therefore, theta is equal to the inverse tan of 2, which is approximately what in degrees? What angle do we have there? Do I have to go and work it out myself? 63 degrees. 63.4 degrees. So now we need to answer the question, what is the resultant force? Well, we could do it a few ways. First of all, I can say that if I've got 63 degrees in that direction, let's have a think about it. If I've got true north in this direction, I could give you a few things. First of all, this angle in here, I could subtract 63 degrees from 180, and that's going to give me a true bearing, if you like. So I could therefore say that we've got a force of 44.7 newtons, my resultant force. My resultant force is 44.7 newtons, and I've got a bearing of 180 minus 63.4, which is what? About 116.6. At 116.6 degrees true, if you like, a true bearing, or we could say that it's 44.7 newtons, and we could say that it's 63.4 degrees east of north. I guess you're going to see either way, they're both right. Okay, you can see there that this angle here being 63.4 degrees east of north. Oh, sorry, east of south. My bad. All right, east of south. Silly. All right, so that's pretty much. That's resolving four forces. We've got a resultant. It's a vector, magnitude, and direction. Now what I'm going to get you to do is have a go at this one. Now, by the way, this is one of the harder questions from 8.4, which was resolving vectors in their components, horizontal components and vertical components. But you know what? It's just trig. What I'm going to do is I'm going to pause this video. I'm going to give you guys a good time to have a go at this question. All right, and if you can do this question, I'm pretty confident that you can do all the questions from 8.1 to 8.4. All right, so we'll pause and go resume. All right, so what you can do is, first of all, I have joined my vectors head to tail. I've drawn a diagram. That diagram, if I see a correct diagram and you then do the incorrect mathematics, I will be giving you marks. I will be rewarding you for doing correct diagrams. You need to be able to do that. So a tug, the resultant force is 62.5 degrees west of north. In other words, we're basically starting north, we're heading towards west, and that is at 62.5 degrees. Now, not that that's necessary, but given that this is a right angle triangle, or in other words, the angle between south, north, and west is going to be 90 degrees. Therefore, because a triangle adds to 180 degrees in terms of their internal angles, therefore there's also 27.5 degrees in there. Not that I needed that, but I just have done that. So what we need to do, now I've called tug 2, I've called that distance or that force, the magnitude of the force, I've called the magnitude of that force x, just for the time being. And what we can do is, using trigonometry or SOHCAHTOA, I can then say, all right, I'm going to get a relationship between the horizontal force and the vertical force using Pythagoras' theorem. Now, of course, I wasn't given this 27.5 degrees. I could use that angle if I wanted to. But you know what? We're just going to use this angle 62.5 degrees. So what we're going to do is we need a relationship, which is a trig ratio. So I'm going to say that I'm looking at the opposite and the hypotenuse. So therefore we can say that sine of 62.5 degrees is equal to my opposite, which is that distance x over 235,000. Now we've got to solve for x. So what we can say is that x, or the magnitude of x, if you like, is equal to 235,000 times sine of 62.5 degrees. And similarly, what you'll notice though, what you'll notice is that the angle opposite, if we're looking at the component opposite to an angle, we use sine. Why? Because sine has the opposite. If we're looking at the component which is adjacent to that angle, in this case the vertical, we're using cos. That's essentially what we're doing. This is the sort of thing that I don't want. You should really, in the future, almost skip this step and go straight to step 2, because you're going to do this so often. So that is x, and then we can say that that cos of 62.5 is equal to x over, y over 235,000. So therefore y is equal to 235,000 cos of 62.5 degrees. And this is breaking up a vector in their perpendicular components, horizontal and vertical. So what we need to do now is work that out. So I've got a value of, so tug 1, which was x, was, sorry, what were you saying it was, Matthew? What were you saying that the horizontal tug 1 was? Or sorry, this one? Yep, so that's 208,000. 448 will do. Newtons, and the y component should be less. The y component should be less. 511 newtons. So what we've done is we've broken down those two forces into the horizontal and vertical components which make up that resultant force. Are there any questions about this stuff? Is it not as bad as you think? As you might have first thought? Okay, I'm going to stop there, and I'm going to get you now to have a go at the questions from, I think, start with 8.4. That doesn't mean that you shouldn't be doing 8.3 and 3 questions, but I think you should start with those ones.